This video, in this video, we're going to talk about the node voltage part of the problem in your midterm. And the way you set up the node voltage, you take the following steps, right? So let's analyze the steps. Number one, we label the nodes. And in our nodes, we can have what? Our intersection. Sorry, we label the nodes off our intersection, which is here. Hold on. So bad handwriting. Intersection. The second we want to label is source. All right. So at the intersection above the source, then we want to do the sign. We want to go ahead and draw current at node. Third is sign closest to node. Once you understand this concept, then you apply KCL. Okay, those are the 4 steps. And this kind of is done in 2 parts, but we'll talk about that. So first is, what is the intersection? The intersection always is here. We're going to assume this is the intersection. I can assume also it's the intersection, but they're going to have the same equation, so you only use one. Then you want to draw, so you have the intersection, and we're going to call this VA. At node A, you have VA. Then you have the source. So above VS, I have V1. Okay, that's the second step. Then what you want to do is you kind of want to draw the currents, I1. And then you want to draw I2 in this direction and I3 in this direction. Now this is a standard. It really doesn't matter how you draw the currents, but we're just going to assume the standard as a teaching tool. Okay, you can really draw it however you want to do it, but I'm going to explain to you why I use the standard. Now what you want to do is do the voltage polarity drop. So the polarity drop is plus minus, plus minus, plus minus, plus minus. And then I2 obviously is going here, right? I2 is in this direction, so I1 is this direction plus minus, and then I1 obviously is going to go this direction, right? So it's plus minus, I3 is coming down, so it's plus minus, I2 is going this way, it's plus minus, and then I2 is obviously going here. Our sum is here, okay? When you do that, then you circle the sign, it's close to the node. The sign closest to node is VA. This is the sign, right? The sign closest to V1 is plus here. The sign closest on this path, closest to VA, is here. The sign closest to VA is here. So these are the closest signs. From here, you draw out your equation. So we finished out your source, we finished here. Draw the currents at the nodes, and then we went ahead and did this sign closest to the node. Now we apply our KCL in 2 parts. First thing we do is we define I1, I2, and I3. And what I mean by define is we're going to set its value. So I1 will be V over R, but it's minus VA. The sign closest is minus sign VA. Okay. Plus V1 over. The path is R2 and R1, the entire path. R2 plus R1. Okay. I2 is minus VA, R4 and R5. And I3 is simply plus VA over R3. Okay, so with this in mind, let's first kind of define this problem. Okay, so the definition of this problem is going to be, I probably wrote this plus VA over R3, so plus VA over R3. So what is VA? We don't really know. V1 is clearly 100 volts going down, so that's plus 100. R2 is 50, and R1 is 50. minus VA plus 100 over 100. Here it's minus VA. R4 is 25, R5 is 25, so 25 plus 25 is minus VA over 50. I3 is VA over R3, which is 100. So you have 1, 2, and 3. Okay. Now, how do you define this? Well, you have to define it through the KCL. First, you define it. Now you apply KCL. Okay. And we have to do this side by side. So what you're going to do is we're going to, the way the problem is going to work is we're going to go here. We defined it here. We're going to solve KCL here, and we're going to go back and get the answer here. So we apply KCL to node A, and what happens is we define the currents coming into a node is positive, and we say plus I1. I1 is coming in, so it's plus I1. I2 is coming in, is plus I2. I3 is coming out, is minus I3, is equal to 0. So I1 now is minus VA plus V1 over, I'm sorry, this is wrong. Let me replace that. I1 is now defined as, here, we defined as minus VA plus 100 over 100. Plus I2 is minus VA over 50 from here. I3 is plus VA over 50. All right. Now, how do I do this? Okay. Well, there's a magical 1 in front of the VA. So if I clear this, I'm going to go ahead and clear. There's a magical 1. So it's 1 over 100. So I get, what is 1 over 100? If you have to guess, please use your calculator. 1 divided by 100, I get 0.01. So it's minus 0.01 VA. What is 100 over 100? 100 over 100 is 1. So that's the first one. Again, that's 1 over 100. Put in your calculator, you get 0.01. Now, what is 1 over 50? So I have a plus. Plus sign comes down. 1 over 50 is 0.02. So it's minus 0.02 VA. Okay. What is 1 over 50 again? Right? I'm sorry, I3 is 1 over 100. I'm sorry, I made a mistake. I3 is VA over 100. I apologize. Let's change this number here. VA over 100. Just be careful. Plus VA over 100. So what is 1 over 100 again? 1 divided by 100 is 0.01. So plus 0.01 VA is equal to 0. Now what you do is you add up like terms. Here, here, and here, right? Well, before you add up like terms, let's stop here. Let's distribute out the negative signs before you start adding like terms. So we have negative signs here, right? So what are the negative signs? You have minus 0.1 VA plus 1 minus 0. Because plus positive times negative is negative. 0.2 VA minus negative times positive is negative. 0.1 VA is equal to 0. Now you define your equation. You add like terms. You have a like term here. You have a like term here. You have a like term here. So 0.01 plus 0.01 plus 0.02 is 0.04 minus 0.04 VA plus 1 is equal to 0. You solve for VA. Okay, the way you solve it is minus 0.04. VA is minus 1. VA is minus 1 over 0.0. Sorry. VA is minus 1 over minus 0.04, which is 1 divided by 0.04. If you don't know how to do it, put on your calculator, you get 25. 25 volts is positive because they're negative over negative, right? That's the division rule. Which now we get a V over 25, we go back and solve for I1. I1, I2, and I3 from here, right? We put it here. So we write I1 is minus VA plus 100 over 100. You get what? Minus 25 plus 100 over 100. So that's 75 over 100, which is 0.75 amps. I2 is minus VA over 50. So it's 25 minus 0.5 amps. And well, I'm going to explain what minus is in a minute, right? So I'm going to explain that. But let's go to I3. I3 is defined as, again, from here, plus VA over 50, which is 25 over 50, which is, I'm sorry, 25 over 100, VA plus over 100. So this is over 100. This is 100. So that's 0.25 amps. And just put it on your calculator. So if you just get 25 over 100, which is 1/4, you get 0.25. Okay? Long story short. Okay? So what happens? What does this negative sign mean? This negative sign means this direction is opposite. So original current direction of I2 was going in this direction. It's incorrect, and our real assumption is going in this direction. You need to put the answer here and do not change what's up here. If you change what's up here, then this changes, then it gets counted wrong. So this equation here is reflected up here. In this answer here, you simply show the directions different. Okay? And that's how you handle node voltage.